Hi, my name is Soumya Thomas, and today I'll be recommending an item of purchase for my lab where I work at UT Southwestern. So I work with Dr. Yassine Lahir in his exploring sex effects in rehabilitation medicine, and I like to date Dr. Yu Chen Chong. Um, so the purpose of our lab is to see what the role of estridyl is on our muscles. Estridyl is a certain type of estrogen. So we found that women are more likely to tear their ACL and and two studies have shown that these injuries are more likely to occur during the luteal phase, which is after ovulation. This is interesting because this is when hormones like progesterone and estrogen are at their highest concentration. Additionally, estriol has been shown to affect muscle laxity in one of our labs and also muscle fiber type. So we are also wondering if estriol can also affect muscle control. So estridyl receptors are found everywhere in the brain, such as the frontal cortex, sensory motor cortex, and cerebellum. The sensory motor cortex and cerebellum are very important for voluntary movement. So if estrogen concentration could affect these receptors could have effect on these neurons that could control our movement. For example, making movement more difficult to achieve or maybe slowing down. Or are like reducing the intensity of muscle activation. So how can we test the effect of estridyl on the spinal motor neurons? So we do this by using transcranial magnetic stimulation. How this works is that we have a magnetic coil here that's connected to this power generator. This generates a magnetic field, which generates a current going in the opposite direction in when you place it over the body. So we use this magnetic stimulation over the spine paired with electrical stimulation to induce a muscle twitch. Differences in the intensity of these muscle twitches between ovulation and menses can tell us about the effects estridyl has on the spinal motor neurons. However, we've ran into a few problems with our current TMS device, which is shown here. This is the current coil we use in the lab. The main problem is that it overheats quickly. So this coil will be too hot and then we require at least 30 minutes to cool down, which cuts down our data collection time. Additionally, this handle is bulky, which means that it doesn't lay completely flat on our subject's back like we would like. Additionally, this coil is not as focused as we would like it to be. For our study to be approved, we need to prove that this TMS is only activating these descending spinal tracts. So we need to find the most focused coil. So with these all in mind, I was wondering what the best magnetic coil is available on the market that we could easily use for our study. So the most focused coil available from Maxim is the D11 cone coil. The shape of the coil, the angle allows the magnetic stimulation to penetrate deeper and be more focused. However, this shape is not well accustomed to spinal stimulation because it won't sit flat on the spine. The flattest coil available is the D7D alpha flat coil and the D alpha coil. Neither of these have any casing around it. So this reduces the barrier between the magnetic stimulation and the skin. However, they're not as focal, as intense as the double coils pictured earlier. The coolest coil available is the D70 air film coil, which has these fans attached. However, these fans are also quite heavy and it would probably not be very uncomfortable for our participant to put that on their back. The strongest coil available is the S90 standard coil. It's a circular coil, and however, because it's so strong, it also activates a large area, and so it's not very focused. So in conclusion, I decided that the D70 alpha flat coil would be the best option for our lab. It's the most focused available and allows the most maximum contact with the participant. And additionally, the handle allows for easy handling. And these are my works cited. Thank you.